Dear students, we all know that we are suffering from the corona epidemic, and at this present time when there is a shortage of medical supplies and also our daily needs, we ought to have a technology that can make us ready for the future epidemics like this, and also apps that can be helpful in this difficult time. This could only be done if the children like you learn science and use it for the works like these. In the last lecture, you have studied about the friction. I hope you must enjoyed learning it. Well, today we are going to know about the types of friction. I expect all of you to pay attention sincerely. After studying, you will be able to number 1 differentiate between static and sliding friction, number 2 conclude that friction is a self-adjusting force, number 3 explain the reason for using wheels extensively in transportations, number 4 give example of situations where sliding friction is converted into rolling friction. Now we discuss activity number 3. Friction is a self-adjusting force. So we take a large box. On this box we applying the force F from the one side. We observe box remain at the rest. Now we increase the force to the 2F times. We again observe that boxes remain at rest. From this we conclude that at the stationary state, force of friction balance the applied force. This force of friction is called static friction. This activity shows that force of friction is increased by increasing the applied force. So we can say that static friction is a self-adjusting force. When force increases beyond this limit, the boxes just start to move. This is the maximum value of static friction is called limiting friction, in which boxes just start to move. After it, the box is sliding over the surface of flow. That is called sliding friction. Now we define all these frictions one by one. Now we define the static friction. The force of friction which balances the applied force during the stationary state of body is the static friction. The maximum value of the force of static friction comes into play when the body is just sliding over the horizontal surface. It is called limiting friction. Now sliding friction. The force of friction between the two objects when one of them is sliding over the surface of other as a sliding friction between them. Sliding friction is smaller than the static friction between the same two surfaces. We commonly observe that when we push a heavy box at the start, we apply the more force to start it moving. Then it has the static friction. Once the boxes start moving, we have applied the less force, then it has the sliding friction. We know that friction exists due to the interlocking of the irregularities of two surfaces in contact. Now we discuss one questions related to the friction. Questions: why sliding friction has a less value than the static friction? Answer: it is because once the object starts sliding, contact point of the one surface do not get enough time to lock into the contact point of the other surface. So that is why sliding friction has a less value than the static friction. Now we discuss the next friction, that is a rolling friction. The force of friction that comes into the play when one body rolls over the surface of another body. Its value much less than the sliding friction. This observation led man to invent the wheels, because rolling friction has a very less value than the sliding friction. Now we discuss a question related to the wheels. Question: wheels are used extensively in the daily life for the transportations. Give reason for it. Answer: wheels have the least value of friction. They save labor and energy to a great extent. So it is because wheels are used in daily life for the transportations. Now we discuss another questions related with the rolling friction. Question: why laborers prefer placing logs under the heavy machines while moving them from one place to the another? By placing the logs of wood under the machines, it is because rolling friction has a less value than the sliding friction. Now we discuss the activity number 4. Sliding friction is less than the static friction. For this activity, we take a rectangular wooden block, round pencils, drawing pins, pen, marbles, and thread. Arrange the petals as shown in the diagrams. One end of the thread is connected to the rectangular wooden block. Second end of the thread is connected to the pen. This thread passes over the pencil, which is held in between the drawing pins. So this pencil is free to rotate. It acts as a pulley. Now we place some marbles in the pan. We increase the marble one by one until this wooden block is start moving. When this wooden block is start moving, we remove the some marbles from the pan. It shows that when the wooden block is start moving, it requires a less force, but at the start it requires a more force. So at the start we adding the more marbles, but when a wooden block is start moving, there is a requirement of the less force, so we add the less number of marbles. Now we again discuss the activity which we already discussed as the friction is increased by increasing the weight of the moving object. Now this activity discussed as the sliding friction is less than the static friction. For it, we take a wooden block, one spring balance. A wooden block is placed on the floor. Now we pull the wooden block with the help of the spring balance. Now we note the reading of the spring balance when the block is just start to move, and after some time when the block is sliding over the surface. We noted the difference in reading. At the start, reading of spring balance is more. When block is start moving, the reading of spring balance is reduced. For example, if at the start of the reading of spring balance is 5 Newton, when block is sliding, the reading of the spring balance may become the 4 Newtons. So it shows that sliding friction is less than the static friction, because at the start there is a static frictions, but when the block is sliding, that is a sliding friction which has a less value than static. Now we discuss the activity number 5. Rolling friction is less than the sliding friction. For this activity, we arrange the same arrangement as we done in the activity number 4, but this time we place a round pencil below the wooden block. Now we observe this time we put the small number of marbles in the pan, and we observe this block is moving over the pencils. This shows that rolling friction is less than the sliding friction, or we can convert the sliding friction into the rolling by placing the round object below the object we carry from one place to the another. Now we perform an activity which shows that rolling friction is less than the sliding friction. For this activity, we take a mobile phone, one charger and connected lead which connect the mobile phone and charger. For this activity, we take a heavy charger and one round bottle which is placed at the end of the table act as a pulley. Now we hang the chargers and observe. We observe phone is easily slide on the table. Now we place the same phone on the round pens and we take same charger which is less heavy than the previous one. Now we hang the same chargers down the table and observe. We observe now the mobile phone is moved easily from the one end of the table to the other. It shows that rolling friction is less than the sliding. Now we perform the another activity in which we push a heavy cylinder. When we push it, we observe that at the start we apply the more force. When it starts sliding, we apply the less force. Now observe. Now we roll the same cylinder. Now we observe that there is a less force required to rolling the cylinder. Cylinder is easily moved from the one place to the another. So this activity shows that rolling friction is very less than the sliding friction.